So, in this episode, we shall discuss some important properties of inverse of a function. And the first property or the theorem is the inverse of a bijection is unique. Now suppose f is a function from a to b, and also suppose it is a bijective function. And now as per this theorem, the inverse of the given bijective function f is unique. And now let's suppose the inverse of this function is not unique. And that will mean we have got more than one inverse of the given function f. And now let's suppose the function g from set b to a and the function h from set b to a are two inverse of f. And now the inverse of the function will be unique when g is equal to h. And now we have to prove the function g is equal to the function h. And the function g will be equal to function h if and only g of y is equal to h of y for all y which belong to the set B. And now to prove it, let y be any element from set B. And suppose g of y is equal to x1 and h of y is equal to x2. Now g of y is equal to x1. Then that also means f of x1 is equal to y, because the function g is the inverse function of the function f. And similarly, as h of y is equal to x2, then that also means f of x2 is equal to y, because h is the inverse function of f. And now since f of x1 is equal to y and f of x2 is equal to y, so we can also write f of x1 is equal to f of x2. Now f is a bijection, which means it is also one-to-one function. And in case of a one-to-one function, you know it very well that if f of x1 is equal to f of x2, then that also means x1 is equal to x2. So now we have x1 is equal to x2, but x1 is equal to g of y and x2 is equal to h of y. So we can write g of y is equal to h of y. And that's what we wanted to prove. So that means g of y is equal to h of y for all y which belong to set B. And that means the function g is equal to function h, or the inverse of a bijection is a unique function. And now we shall discuss another important theorem according to which the inverse of a bijection is also a bijection. Now let f be a function from a to b, and suppose f is a bijective function, and also suppose g is a function from b to a such that g is the inverse function of the function f. And now we shall prove that the function g is also a bijective function. Now the function g will be a bijective function if it is both injective and surjective. So let's first check whether this function is injective. Now let y belong to set B, and suppose y1 and y2 are two elements from the set B, and g of y1 is equal to x1, and also g of y2 is equal to x2. And now since g of y1 is equal to x1, then that also means f of x1 is equal to y1. Why? Because g is the inverse function of the function f. Similarly, g of y2 is equal to x2. And we can also write f of x2 is equal to y2, because g is the inverse function of the function f. So now since g of y1 is equal to x1 and g of y2 is equal to x2, so we can also write x1 is equal to x2. Then that also means f of x1 is also equal to f of x2, because f is a bijection. But f of x1 is equal to y1 and f of x2 is equal to y2. So that means y1 is equal to y2. So that means if g of y1 is equal to g of y2, then y1 is also equal to y2. So therefore g is an injective function. Now let's check whether the function g is also surjective. And now the function g from B to A will be a surjective function if every element x which belong to set A has got a pre-image in the set B. So that means the function g from B to A is a surjective function if for all x which belong to set A there is always a pre-image in the set B. Now suppose y is an element from set B, so f of x is equal to y, because f is a function from A to B. And now g is the inverse of the function f, so that means g of y is equal to x. So that also means for every element x which belong to set A, there is always an element y in the set B such that g of y is equal to x. Or we can say every element x from the set A has got a pre-image in the set B, which means the given function g from B to A is a surjective function. Now the given function is injective as well as surjective, so that means the given function g is a bijective function. So if f is a bijection, then g, the inverse of f, is also a bijection.